Pioneers of Power is a vision for how we're going to meet the needs of our customer way into the future. We need to rethink how we address some of the biggest challenges facing mankind today. Pioneers of Power is going to enable us to protect our planet, to save our world, and it's going to enable us to explore our universe. Defence has a mission that's to protect our way of life, but defence also has a huge impact on our environment. What we're doing is working with our military customer to see how we can still deliver the operational output that they need whilst minimising its impact on the environment. The first key element of Pioneers of Power is sustainability and sustainable propulsion. How are we doing that? Sustainable fuel is a great example where we will literally take carbon from the air, synthesize it, and produce a synthetic fuel product that can then work in our engines. It still creates an emission, but the overall net zero package comes together, and overall we have a net zero impact on the environment.
Synthetic aviation fuel is not based on fossil fuels. By using synthetic aviation fuel, we're able to be a more sustainable business because we're reducing our reliance on fossil fuels. We're designing our future products, such as Tempest, which is the next generation of fighter engine, to be fully compatible with synthetic aviation fuel right from the start. We're also making it a more electric engine by designing in the embedded electrical starter generator, which will be able to reuse power from the engine to power the aircraft's electronics, thus reducing waste. Additive manufacture, it allows us to unlock geometries we were never able to have beforehand. You can get much more complex shapes inside the component. You could have much more efficient cooling systems. You can have much better heat exchange. You could reduce the part counts. This means you can have a much more cost-efficient engine, but also by reducing the amount of cooling air needed within a part, you get a much more efficient engine. So that just reduces the amount of fuel you need as well.
What else are we doing? We're looking at how we can use electrification and electric power to replace that dependence on fossil fuel. We've produced an aircraft that's capable of flying at 300 miles an hour exclusively using electrical power. That is a world first. That technology is beautifully placed to work in elementary flying training for military cadets. So the pilots of the future can start their training career on a fully sustainable green platform. Here in Bristol, we're committing to get this site net zero by the end of 2022. All of our buildings are coated in solar panels. They've got LED lighting, so we've really focused on minimising the footprint inside the production facilities themselves.
3, 2, 1, 0. All engine running.
The second key element of our Pioneers of Power vision is space. It's about getting to space and what we do when we get there.
Tower clear.
Humans are looking to go back to the moon in the next 5 years, looking to create a permanent habitation, a permanent base on the moon this side of 2030, and then looking to move out to explore Mars and the solar system and actually the deeper universe in the coming decades. It's a really exciting time for space exploration. To explore space, you need reliable power, you need safe power, you need power that works where there's no sunlight, power that works where there's no fuel, and power that works where there's no oxygen. There are several different technologies that will enable this human exploration back to the moon and then to Mars and further afield. We're working on gas turbines to power hypersonic planes to take payloads from Earth into low Earth orbit. For in-space travel, to get from low Earth orbit to the moon, to Mars or even further, we're working on nuclear thermal propulsion, really efficient, fast rockets for space travel. We're also using our nuclear expertise to design small reactors that will power bases on the moon or Mars, providing reliable and clean power for astronauts at these destinations. A traditional mission to the moon or Mars using chemical rockets would have to carry tons and tons of fuel. A nuclear reactor uses only a few grams of uranium. That means these systems are much lighter, which means you can take a lot more payload or travel a lot faster to Mars, which is really important for human spaceflight. Right now, here at Rolls Royce, we have over 60 engineers and scientists working on these amazing technologies for space exploration. We're currently working on the early concept design, development and testing phase, both for our two-stage to orbit system and our nuclear systems. We've already built a small-scale prototype demonstrator of our space reactor, and by 2029, we'll have a reactor ready to send to the moon.
Discovery, roger. Go for deploy.
The third element of our Pioneers of Power vision is digitisation. Ever since we've started taking data off our engines and proactively using that to manage their service life and improve the availability of those products for our customers, we've been using data. But as we go forward, we'll need to use more data and we'll need to do it in more innovative ways.
So we see digital as an enabler at Rolls Royce. We apply it to every life cycle stage of a power system. In design, automated tools help speed up the design process to increase the speed of delivery. In manufacture, processes such as ALM are used, which have been allowed through digital tools. In inspection, we're using digital inspection tools to allow us to collect more and better data than ever that we can then feed back into the design teams to improve our future designs. One of the projects I'm working on at the moment is VR training. VR training provides lots and lots of benefits. Firstly, it increases the availability of training to our customers, which helps their planes keep flying. It reduces the cost of training, as a physical asset is not needed. It improves the safety of training, as engineers no longer have to work on a physical engine the first time round. And as well, it means that we could have a customer at a base somewhere else in the world. If they have a problem that they've not come across before, they can go into the virtual environment, put the headset on, talk to one of our experts here at the Bristol site, learn how to fix that problem together, and go and get it right first time on the aircraft. So I think it's a really exciting time to work at Rolls Royce. There's lots of really, really good opportunities. So for example here, I am looking at the HP compressor. You can see the whole engine exploded.
This is a really energising environment to work in. You can really get the sense of buzz of excitement because the products we're working on now will be the things that we'll see flying right the way through to our retirement.
We have a really amazing team working on this right now in Rolls Royce. We have been pioneers of power here on Earth, and we will be pioneers of power in space.
Imagine a world of sustainable aviation. A world where our people are immersed in a digital environment, producing twins of those real-world products, where people are exploring the furthest reaches of space. Rolls-Royce is going to be there every step of that journey to fulfill the greatest ambitions of humankind.